Hi all, and in this lesson we're going to review information systems and just have a quick look through some of the basic theory behind an information system. And firstly, the thing to note about an information system is that they're no different to any other system, regardless of whether it's a computerized information system, a paper-based system, or even a system in your body. The human body certainly has plenty of systems: the circulatory system, the respiratory system, and so on. All systems have the same basic fundamentals in that they take some input. In the case of an information system, that's data. In the case of the respiratory system in your body, that's air. And then there is some process that's applied to it. In the case of the respiratory system example, then that's the lungs extracting the oxygen and feeding it around to the cells in your body. In the case of an information system, we process the data that's input, and there's always some sort of output. And in an information system context, that output is information. Okay, taking the data, organizing it by processing it, and we get to information. The difference being that data is raw facts, raw pieces of factual content, and information is raw facts organized in a way that it creates meaning and it means something to people. So as with all systems, an information system consists of a whole bunch of interrelated parts, and we take that data and we process it and we produce information. That's the concept behind what we're looking at. There are four different views of an information system. There's the external view, which is the view that the user interacts with. Now in our case we're going to develop some online information systems, so the external view will be the form of a web page or a series of web pages. Those web pages we will construct, and we can construct so that they take account of these things here: confidentiality, security and convenience, so that we can actually have different views of our external view, if you like. So we can have different parts of the system that certain people can see, and certain people parts of the system that certain people can't see. One of the other views of our four main views is the internal view, or the physical view. So that's talking about how the data is actually stored and manipulated under the covers in the database. And this is the view that the technical people, or our database, our information system developers would maintain and develop, and obviously then technical people would install that system and maintain it to keep the system running. We've then got what we call the conceptual view. So in creating one of these systems, we need to first plan it. Planning is key to everything, and it's no different in an information system. And in planning an information system, we use a process called object role modeling. And that process results in the development of one of these things, which is a conceptual schema diagram. Just a small example of a conceptual schema diagram. But that diagram is constructed in the planning stage, and it defines all of the different entities and the relationships that exist between those entities that make up our information system, and we represent it in diagrammatic form like this here. And we use that to actually construct our database that's going to underpin our information system. And the final view is what we call the logical view. So obviously if we construct this system, we've planned it, we've constructed our physical view, and then we need to be able to link that to our external view. So there's got to be a link between what the user sees and how the system actually works under the covers, and we call that the logical view. So it's really how the data or the information gets arranged and is communicated out to the user then in the external view. There's a few forms of information systems. Now most of these forms we're not actually going to cover as a part of this course. However, just being aware that different forms exist is sufficient. So there's a hierarchical form of an information system. By hierarchy you can see a couple of examples here. This is a tree style hierarchy, and this is more of a traditional, I suppose, hierarchical information system. The point is that all of the branches, regardless of where they come from, or where they are, all originate ultimately from one root node. Okay, one single root node at the top, and that identifies a hierarchical system. These have their benefits, but certainly one of the disadvantages of this style of system is that it can be quite inflexible, and it's quite hard to sort and restructure. If you need to restructure that system, then there's quite a bit of work to do to make that happen. One of the other ones is a network information system. So this is where the child nodes can have more than one parent, as opposed to back here where each child node has one parent and one parent only. So each child node, so this is the child node here, only has one parent, only relates back to one parent and one only. With a network system, that's not the case. Each child can have more than one parent, which is great for enabling fast searching and working your way through the system, but it becomes really complex and hard to maintain, particularly as it gets a lot larger. The type of information system we're going to certainly spend all of our time looking at is a relational information system. And it's by far the most widely used. And a few rules around the relational information system is that all of the data is arranged into what we call tables, where every table gets a name. So here is a table that we would give a name to, and the tables get represented as a grid, where that grid is, like any table, a series of rows running across and columns running down. A few rules around relational systems. In a relational database, in order for a relationship to occur, then you must have at least two tables. Okay, it's very difficult to have a relational database with only one table, because it's not relating to anything else. So generally it must consist of at least two or more related tables. Tables are related by sharing a common field. That's how the relationship is formed. So there is at least a common field between each of the tables in the database. Each table consists of rows. Those rows are what we call records. So coming back to a quick example here, each of these rows is what's called a record. A record contains all of the data that relates to one particular item. So all of the data in this particular row all relates to that one ID number. That's their name, that's their age group that they're in, that's their house that they're in, and that's the event that they compete in. Columns are the other things. Each of the columns are generally categories of data, if you like. So here we call them fields. So this is a field, a name field, that is storing all of the same type of data in each of those, and they are names. The intersection, so where a record and a field intersect, or where a column and a row intersect, we call that a cell. And a piece of data that is stored inside a cell is we call an instance. We refer to it as an instance of that data. And there can be multiple instances of the same piece of data. That's quite possible. And the term we use to describe an empty cell is a null. So a cell that has no data entered into it at all is a null, and that is very different from a zero value. A zero value is actually a value. It represents that cell has no value. But a totally empty cell with nothing in it we call a null. Few final rules about relational databases and tables. Each row must be unique, so no rows can be repeated exactly. There must be something different about each of those rows that makes them unique. Each table has what we call a key, or a primary key, which is a unique identifier. So in this particular example, you can see this ID number here is uniquely identifying each one of those rows or records. So that's a requirement. Sometimes a key will be in what we call a simple key. In other words, it only uses one field to identify all of those rows. Sometimes we'll call it a composite key or a compound key, which means sometimes we need to take two fields and combine them in order to create our key field, a unique identifier field. And one of the other rules is that each cell can only contain one data item. So if you have more than one data item inside one of these cells, then that is not conforming to the rules of a relational database. So in our next lesson, we will have a look at an example, a bit more of an in-depth example of using a relational database.